7 over 2, which is 3.5. So I'm putting a hole there where that point is. And I'm just going down the list of things that we've found. Next thing we found was the horizontal asymptote. So at y equals 2, there should be a dotted line. Next is, it says, what is the 0 of the function? That was at 1/2. So at 1/2, 0. So that's right there. You don't really need the domain and range here. And we just found the y-intercept. It was 0, -1. Okay. In my opinion, which, I mean, I didn't write this book, but in my opinion, this is enough to get an idea of what the graph looks like. You don't need 4 points, so I don't care if you have 4 points. I want an x-intercept, a y-intercept, any holes in the graph marked, and then if that happened to all be, say, on this side, then I would need like another point on the right. By the way, to find another point, say you wanted another point or you needed another point, you just plug in a number. So, like if I wanted another point over here somewhere, I'm going to plug in, say, -2 into the equation. So, and you can use the original equation or not, it doesn't matter. You can use what's left over here, like this part. So I have f of x equals 2x minus 1 over x plus 1. Yes? Yes. Now, I'm not saying this is a point you would have to plug in. I'm just saying if we get to a problem where there's nothing on one side, this is how you would find the point. So if I plug that in, I have 2 times -2 minus 1 over -2 plus 1. That's -4 minus 1 over -1. So that's 5. So that's the point, -2, 5. So -2, 5 is there. And so what I'm going to do is I know all of these graphs kind of do this curvy thing. I guess the person on the, they do this curvy thing. So that's the way we're going to draw it in. I know it's not supposed to cross or touch an asymptote. Occasionally it will, the horizontal asymptote, but so I'm just going to draw it in kind of like that. It's supposed to be getting closer and closer to those pink and green lines. So, see, I would have drawn it like that whether I had 2 points on that graph or not. That's what I was saying. 1 point's sufficient. But I do want it to have a y-intercept, x-intercept if it has it. Of course, the asymptotes, those are important. And the hole, that's important. And if you need another point, if you're not sure how it goes, then by all means. But if not, that's good. Probably good. just as good as all the other guys. So when you get to the homework, you can ignore that it says you have to have 4 points on each side. You know, as long as you have enough. Alright. Now we're going to do the same thing on the next problem. Okay, so the first question is, what is the equation of the function written in completely factored form? So I want you to go ahead and factor this, and I'm going to call on you. Somebody. If you get done with that, you can go in and fill out the rest of them. Here, I'll put the graph back down if that helps, Maria. Those asymptotes are boundaries. That's how we know how wide to draw it. Okay, the top doesn't factor, but Donna, what'd you get when you factored the bottom?
I didn't finish it.
Oh, okay, go ahead. I'll give you a sec. It's just 2 numbers to multiply to give you 4, but add to give you 6. When you're ready, Donna.
X plus 4 and x plus 2.
Very good. Question? Okay, again, I'm going to keep asking you questions about each one. So if you haven't figured out the next one, the vertical asymptote, go ahead. And you can keep going if you need to, because I'm not asking questions if you finish those other ones. Stop me at any time if you have questions. Tyler, what about the vertical asymptote?
X equals -4.
Yes. Whatever is the non-canceling, I'm going to be American this time, there we go. Non-canceling factor, whatever that is, that is what you say equals 0, which is exactly what he said. X plus 4 equals 0. So x equals -4 is your vertical asymptote. Am I confused by that? Okay, move on to the whole if you haven't done that yet. If you have, go ahead and keep going. Yes, ma'am.
Since it has nothing on top, because like they've already canceled out, do you put a 0 or just
would say
do the
none.
bottom?
Are you talking about the
Hole in the graph.
hole in the graph? Oh, let's see. It would. That's a really good question. No, it'd be like there's an understood 1 there.
Okay.
I don't know why I didn't know that. COVID brain, I'll call it that. Okay, Maria, how do we find the hole in the graph?
The cancel factor.
Yeah, it's the canceling factor. Or if there's more than one factors. But yeah, there's just 1 there. Sometimes there isn't a canceling factor, and so you'd put none for the hole in the graph. So x plus 2 equals 0, and x equals negative 2, but I need an ordered pair. So this is what Shelby was asking about. If there's nothing left on top, then there's still a 1 there. And then we just plug in negative 2. 1 over negative 2 plus 4. So that's 1/2. Move on to the horizontal asymptote if you haven't yet. Be able to tell me, is it top heavy, same heavy, bottom heavy? All right, Rebecca. What kind of heavy is it?
Bottom heavy.
Bottom heavy. So you remember what it's supposed to be if it's bottom heavy?
No.
That's okay. If it's bottom heavy, it's just y equals 0. So actually, bottom heavy is the easiest. There's no work at all with bottom heavy. It's just y equals 0. Boom. That's it. Now we're going to move on to the zeros, which is kind of tricky. You would take whatever's left on top and set it equal to 0. What's left on top? I mean, you cancel. 1. 1 can't equal 0, right? So what was it, 0? What's the 0? There aren't. Yeah. None. And that makes sense, because think, if the horizontal asymptote is y equals 0, then it's not going to cross the x-axis. So that's why there's no. That's why there's no zeros. See if you can write down the domain and range. Remember, the domain is everything, negative infinity to infinity, except for the vertical asymptote and the x-coordinate of the hole in the graph. And the range is everything except for the horizontal asymptote and the y-coordinate of the hole in the graph. And you just put them in order. Whichever one's smallest comes first. I mean, after the negative infinity, of course. So, Jenna, what's the